Hello everyone, and welcome to this video on the Python programming language. So from one of my last videos, I was asked, how is it possible to get an 8% annual return on an investment? So in this video, I will analyze some exchange traded funds, or ETFs for short, to compare them and see if any of them would have given an average annual return of at least 8%. I will also put a link to that video that I'm talking about in the description below, which shows an investment strategy that you can use to retire within 10 years, given an average annual return of at least 8%. And it doesn't really take into account inflation. Now, before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button. And to be notified about new videos from this channel, hit that bell notification. And the material in this video is purely educational and should not be taken as professional investment advice, as I am not a financial advisor, so please do your own research before making any sort of investment. And with all that being said, let's go ahead and talk about the programming environment. So right now I'm currently on colab.research.google.com, and I'm on it because it makes it easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code, or you can use whatever IDE that you feel comfortable with. Alright, so to get started writing this code, let's go ahead and click on File and click on New Notebook, and a new tab open up for you, and then eventually a new cell. So in this cell, I'm going to put in some comments. I'm going to put in a description about the program. So I'm just going to type, this program compares or analyzes 3 ETFs. Okay, and those ETFs will be SPY, VOO, and VGT. Okay, so SPY contains the S&P 500 index, same for VOO, and then VGT contains tech stocks. All right, so let's go ahead and create a new cell. So I'm going to click this code button here in the top left to do that, and I'm going to import the libraries that I need for this program. So I'm going to import NumPy as NP. I'm going to import pandas as PD. I'm going to import Seaborn as SNS, and then I'm going to import matplotlib.pyplot as PLT, and I'm going to give my plot a style. So I'm just going to type plt.style.use, and I'm going to use 538. Okay, so I'm going to go ahead and run this cell by clicking this button here to the left, and this will let me know if I made any mistakes as well. All right, let's go ahead and create a new cell, and now I'm going to load the data. So I'm going to load those ETFs. So to do that, just type from google.colab import files, and then type files.upload, and let's go ahead and run this, and then click on choose files, and I'm going to upload all 3 of these files here. Okay, and they're almost done. Okay, so let's go ahead and create a new cell now that the files have been uploaded, and let's store the files. So I'm going to create a variable called SPY and set it equal to pd.read_CSV, and I'm going to put in the name of that file, which is spy.csv. I'm going to create a variable called VOO and set it equal to pd.read_CSV, and it's going to read in the VOO.csv file. And then next, I'm going to create a variable called VGT and set it equal to pd.read_CSV vgt.csv. Okay, so that's the name of, or here's the name of all 3 of the files that we've uploaded. So we're just going to read them and store them into these variables. So let's go ahead and run this, and now let's create a new cell, and let's print the data from all 3 of these files. So just type print SPY. I'm going to print VOO, and I'm going to print VGT. So let's go ahead and run this. Okay, and so there we go. All right, so what's important here is that we have the same number of rows in all 3 files, and the same dates. So for SPY, I can see that we have data from 1/3/2011 to 12/31/2020, and it contains 2,517 rows of data and 7 columns. All right. Then if I look at VOO, I can see that it has the same start date, it has the same end date, it has the same number of rows and the same number of columns. And then if I look down even further at VGT, I can see that it has the same start date and it has the same end date and the same number of rows and 7 columns. All right, and we can't see all of the columns in the data set, which is indicated by these 3 dots, but that's okay because I plan on only using the adjusted close price column from all 3. All right, to do the analysis. Okay, so let's create a new cell. And what I'm going to do is I'm going to create a new data frame to contain the adjusted close price for all 3 ETFs. So I'm going to create a variable called df and set it equal to pd.dataframe. All right, so I'm going to create a date column for our data frame. So I'm going to set this equal to SPY date. Let's do we'll just do date there. So I think that'll be good enough. Next, I'm going to create a column called SPY to store SPY's adjusted close price. So just type SPY close, and I should note that I could have used any 3 of these ETFs for the date. I just chose SPY because that's the first column I was going to create. All right, so next I'm going to create a column called VOO, and I'm going to set it equal to VOO adjusted close price, and SPY needs to be adjusted close price as well. All right, and actually I need to put dot values here for both of them, and then I'm going to create one more column, VGT, and I'm going to set this equal to VGT dot VGT adjusted close price dot values. All right, and then I'm going to set the date as the index. So I'm just going to set df equal to df dot set underscore index, and then put in pd dot date date time index, and then put in the date dot values. All right, and then let's show the data. So I'm just going to type df here, and let's see what we get. All right, so that looks really good. So now we have this new data set with all of the adjusted close prices for the 3 ETFs. So let's take a look at this more visually. So we're going to basically plot the data. So I'm going to create a new cell, and here we're going to plot the data. So let's type plt.figure and then give the figure a figure size. So just type fig size equals, and I'm going to do 14 by 5. All right, and then let's plot these data points. So just type plt.plot, and then I want to put the index on the x-axis and then the adjusted close prices on the y-axis. So that's going to be SPY for this data point, or for this plot, and let's set the label equal to SPY, and let's set the color equal to blue. Okay, and I'm just going to highlight this, and I'm going to copy it using Control C, and I'm going to paste it 2 more times using Control V, since everything else will be very, very similar to what I just did. And I'm going to just change these column names, the label, and then the color. So this will be VOO, and then this will be VOO, and then I will make the color orange. And then I want to plot the column VGT. The label will be VGT, and then the color will be purple. Okay, and then let's give the x-axis a label. So just type PLT.x label, and that's going to be the date. Let's give the y-axis a label. So just type PLT.y label, and I'm going to put ETF price USD, and let's give this a legend. So type PLT.legend, and let's give it a title. So PLT.title, and I'm going to put historical prices, and then let's rotate the x ticks. So just type PLT.x ticks, and then put in rotation equals 45 degrees, and then show the plot. So just type PLT.show. Okay, so let's go ahead and run this. All right, so now we can see that data a little bit more visually, and from the looks of it, it looks like VOO's price is getting further away from SPY's price. All right, so it seems like the two prices for these two ETFs were very close back in 2011, and then as time went on, it seems that the prices have diverged slightly. And for VGT, it seemed like it was further away in 2011 compared to the SPY, and the price has gotten much closer to the price of SPY over time. Okay, so let's actually compare the prices between VOO and SPY, and then let's compare the prices between VGT and SPY. All right, so I'm going to create a new cell, and what I want to do is I'm just going to highlight all of this. I'm going to copy using Control C. I'm going to come down here and I'm going to paste it using Control V, and then just change a few things. So I'm going to get rid of these two plots, and I'm going to create a new column. So I'm going to call this column VOO minus SPY price difference, or price diff, and I'm going to set it equal to DF VOO minus DF SPY. All right, and then I want to just copy this using Control C, and paste it here using Control V, and paste it here using Control V, and I can keep the color blue. And then for the label on the y-axis here, I'm going to put ETF price difference USD, and then the title will be basically what I already copied, so I'm just going to paste that here using Control V. All right, so let's go ahead and run this. Okay, and now we can see the price difference between VOO and SPY. So indeed, it seems that in 2011 there was less than a $10 price difference between the two, but over the years it seems to have widened, and now there's about a $30 price difference between the two ETFs. Okay, so that's pretty interesting. I'm just going to highlight all this, copy using Control C, create a new cell, and paste it here using Control V. And now I want to compare VGT and SPY's price. So I'm going to create a new column called VGT, and it's going to be equal to VGT minus DF SPY, or DF VGT minus DF SPY. And I'm just going to highlight this right here, copy it using Control C, and then I'm going to paste it here using Control V, and here using Control V, and here using Control V. All right, so let's go ahead and run this. And now we can see the price difference between VGT and SPY. And as we can see, just like we thought from the first chart, the price is slowly getting closer. VGT's price is getting closer to SPY's price. So we can see that here in this chart. All right, so I just think that's pretty interesting. All right, so we're done with all this. Let's go ahead and create a new cell. And now let's do some more analysis since we got to compare the prices a little bit. Let's go ahead and get and show the daily simple returns. So I'm going to create a variable called daily underscore simple underscore returns. And I'm going to set this equal to df. And I want only the columns SPY, VOO, and VGT. All right. And to get the daily simple returns, I just need to type dot pct underscore change and then input 1. And let's show the data. So I'm just going to type daily underscore simple underscore returns. So let's go ahead and run this. Okay. So this gives us the daily simple returns. And I'm going to create a new cell. All right. So I needed those daily simple returns to do all the rest of this analysis here. So I want to show the correlation between the 3 ETFs. So we're going to show the correlation. And you know what? I come up here and I comment this cell as well. And I just put get the daily simple return. All right, let's go back down here. Okay, so to do this is really simple. To get the correlation, just type plt dot subplots, and then let's give that a figure size. So I'm going to set fig size equal to 11 by 11, and then just type sns dot heat map. We're going to input the daily simple returns dot core. And let me just bring this down a little bit. Okay, and I'm going to set note equal to true, so we can see those numbers. And then the format or FMT is going to be equal to 0.2%. So I only want to see 2 numbers after the decimal place. So let's go ahead and run this. And it looks like I have a slight mistake somewhere, and that's right here. So the problem is that true is a boolean and not a string. So there we go. Let's go ahead and run this. And now we have our nice heat map of the correlation. So let's take a look at this to kind of analyze and see these see how these 3 ETFs correlate with each other. So SPY has a 100% correlation to SPY, which of course is expected, right? And SPY has a 99.86% correlation with VOO, and it has a 92.83% correlation with VGT. And this is actually a positive correlation. And then we look at VOO, we can see that it has a 92.81% correlation with VGT, and of course 100% correlation with itself, and like we saw before, 99.86% correlation with SPY. All right, and then I don't need to go on this row at all, or this column here, because we've already talked about all of the different correlations between all 3. But I will go ahead and go through it. So VGT has a 100% correlation with itself. It has a 92.81% correlation with VOO, and it has a 92.83 correlation with SPY. All right. So for those of you who don't know what correlation is, well, correlation is used to determine when a change in one variable can result in a change in another. And a correlation value of 1 or 100% means 2 stocks have a perfect positive correlation. So if one stock moves up while the other goes down, then they would have a perfect correlation, but it will be negative. It would be a perfect negative correlation, which of course is noted by -1 or -100%. All right, so that's basically it for that. Let's go ahead and create a new cell. And now in this cell, I want to show the covariance matrix. All right, for the daily simple returns. So covariance can tell how the stocks move together. So let's just type daily underscore simple underscore returns dot cove and run this, and there we go. So we have the covariance, and the diagonal entries of the covariance matrix are the variances, which we can get as well. All we have to do to get the covariance, let's go ahead and create a new cell. I'm gonna put get the variance. So all we have to do to get the variance is just type daily simple returns dot variant or dot var. So let's go ahead and run this, and there we go. So we can see the diagonals here are the variances, right, as noted here. Okay, so let's create a new cell, and let's get the volatility, which just happens to be the square root of the variance. And volatility will basically tell us how risky these three assets are. So here I'm just going to type get volatility, and to do that we can just type daily underscore simple underscore returns dot std for standard deviation, which is again the square root of the variance. So let's go ahead and run this, and there we go. So now we can see the volatility for all three ETFs, and I'm going to multiply this by 100 just to get a percentage. So let's run this. Okay, so now I can see that SPY has about a 1.08% volatility, or has 1.08% volatility. VOO has 1.09% volatility. Really, if we round that up, it'd be 1.1%. And then VGT has 1.32% volatility. And 10% volatility is considered very low volatility. And again, these assets don't seem to be that risky, which is interesting. And also what's very, very interesting here is that SPY and VOO only have about a 0.01% difference in the volatility. Okay, so that's just pretty interesting. And VGT is actually the most risky out of these three ETFs, but it looks like it's only about I'll say about 0.22% more than VOO and about 0.23% more than SPY. All right, so not too bad. So let's go ahead and create a new cell. And now let's get the daily mean simple returns. So this is what we wanted, right? So let's show the mean or average daily simple return. So to do that, just type daily underscore simple underscore returns dot mean, and let's go ahead and multiply this by 100. All right, and let's run this. And so now what this tells us is that we can expect on average for SPY to give about a 0.056718% return, or at least that's what it has done in the past. And of course, past performance does not indicate what will happen for future performances. All right, So that's important to note. And let's see, VOO is giving about a 0.056911 daily return on average, and VGT has given a 0.081915 percent daily return on average. Okay, so that's interesting. Let's go ahead and create a new cell and let's see what's the average returns per year. All right, so I'm just going to highlight this. I'm going to copy using Control C, then come down here and paste it using Control V, and then I'm going to multiply this by 252, which is about or approximately the number of trading days in a year, and this will let us know on average what's the return for these three ETFs yearly. Okay, so let me just put a little comment here, put annualized returns. All right, so let's run this. So now we can see that SPY will give us about a 14.29% annual return. VOO will give us about 14.34% annual returns, and VGT will give us about 20.64% annual returns. All three of these are better than the 8% return in question. All right, by a good margin. So also what we've noticed here is that VGT gives the most return, or gave the most return, about 6% more than the other two, SPY and VOO, but it's also the most volatile. Okay, so the question was, how is it possible to get an 8% annual return on an investment? The answer may be to invest in an ETF. And in conclusion, again, we can see that there isn't much of a difference between VOO and SPY. Both have a low volatility and give an average annual return of about 14%. So I don't think you could go wrong with investing in either of these two ETFs, SPY or VOO. However, if you had to go with one, you may want to choose VOO because it's slightly, it gives a slightly higher average yearly return, as we can see here. Right, just again, just slightly. It's about 0.05% more. Still not much of a difference. But out of the three ETFs, it seems that VGT would have given about a 6% higher return on average per year. And of course, that return comes with a slightly higher risk, but only about 3% higher. Yeah, only about 3% higher than the other two ETFs. And that is still considered very low volatility. Well, that's the end of the video. And again, this isn't financial advice. If you would like to start investing in your own ETFs, then you can click on the Webull link below and get 2 free stocks on Webull when you deposit $100 or more. And if you would like to become a supporter on patreon.com or get the code and data set, then I will leave a link in the description below for that as well. Again, thanks for watching, and I hope you all have a great day, and I'll see you in the next video.